but I'm going to start with the class. Just right now. Thank you. We're glad to having you on our classroom. We are right now on a laboratory room. So guys are working with some project that they are developing. But we're gonna interrupt the practice so we can give a class so you can see us. Are you ready, guys? This is our competence room. This class is programmable logic controllers. Okay, sit down. Thank you, guys. I'm going to share my screen now with you. This is not the viewer. Okay. What is going on? Okay. So this class, it was supposed to be on next week, but we're gonna see it first. So this is industrial networks. It's unit 3. It's the last class we're gonna see for this course. The next course you're gonna see the next quarter you're gonna see control systems. So unit 4 will be repeated at next quarter. So for industrial networks, those are the topics: type of buses, access control, and industrial network. What are those? The topologies of industrial networks. I'm hoping that we can finish this presentation today, but if not, we can review it on next week. Remember that as you lose this class on your practice, I'm going to give you an extra day on Monday to upload the file, okay, to Schoology. So what a network is, you already should know what a network is because you have been using networks for a long time, even if you haven't noticed it. Well, a network is a series of stations. These stations are called nodes, and these nodes are interconnected in order to translate some information. Okay. For example, when you communicate your computer with your PLC, this is a network. You are setting up a network, so it's something as easy as that. When you connect your cell phones to a Wi-Fi signal, this is a network too, etc. So you already know what a network is. So what you may not know is how the networks are developed. And well, in order to understand what a network should have, we need to know what are the rules for transmit information into that network. Also, we need to know which are the syntaxes for these rules that we need to use to translate information. Semantic and, of course, the synchronization. It means when the network is going to transmit information and when it's going to receive it, okay? So it means, for example, we have here one user. This user may be your PLC, or, well, let's give a general explanation. So maybe this is my cell phone, okay? And I need to transmit a message to my friend's cell phone, okay? This is cell phone number 1, cell phone number 2, okay? So all the rules, the syntaxes, and the semantic that I need to translate this information, it's called a protocol, okay? So the protocol of the network can be very different I mean, I have a lot of different protocols entities. So, well, the protocol can, well, we're going to see on the next slide the different protocols that we have. But this protocol is mainly software programming. Okay, so, I mean, I need to program this protocol, and also I need a communication system. This communication system is a physical cable or a physical media through well, in order to transmit that information. Okay, so this is physical, and this is software or programmed. Okay, uh, this is the OSI model of interconnection. It's a protocol that has been developed as a normative. It was designed for a couple of entities, but it is a conceptual model. It means that when we set up a network, we do not use all the OSI model. We use just parts of this OSI model. So in order to understand what a protocol are, imagine this OSI model as if it were a sandwich. Okay, so I have different layers on this OSI model. For example, we have them here colored: physical, data link, network, transport. All these layers are parts of the communication protocol. And I can choose one of them, or I can choose just, well, not one of them, a few of them, or I can choose another ones. I mean, I don't need to choose all the layers on one single protocol, okay? The one that I should have always is the physical, of course. Physical, data link, transport, and then the last three are layers that help me to understand the information that I am sending. Okay, so we're gonna see one by one what those layers are. For example, well, let me go ahead and we can go back to this slide later. For example, layer one, physical layer of the OSI model. I'm sorry, it's getting. Well, it means that I need to have a physical media, and this physical media will have some electrical features, so I need to know which are those electrical features, and of course the physical components that are going to be used on that media, physical media. For example, transmission media could be guided or unguided. When we have wired connection, for example, when you use your Ethernet cable, or when we have unguided transmission media, for example, wireless or Bluetooth or NFC. Okay, all those are unguided transmission, physical transmission media. Okay, and when we have guided or wired transmission media, we can use a lot of different cables. Those that you have here, twisted pair, coaxial, and fiber optic, or mainly called fiber, just fiber. Those are not the only ones that we can use. I mean, it's the typical, but not the only ones, okay? And with on wireless transmission, the media, the media or the physical media is free space. I think that you cannot see the bottom of the slide, right? But at the bottom there, it says free space, okay? It's pretty easy till now, right? Okay. What about these three different of wired transmission media? Every kind of cable has different features that can help me to transmit the information. For example, if I'm using twisted pair, which is the cheapest or the cheapest cable, I can use it only in short distances because it's not a reliable media to transmit information in long distances. Also, it's a low speed media because I cannot send a huge amount of data through this cable. When on the other hand, when I am using a fiber optic, you already know that this is kind of a trendy. When we hired a new cable system, for example, when you hired Megacable or Telmex, I don't know, they often tell you that they are working with fiber optic, and they highlight this like a main something attractive for in order for you to contract them. Okay, so this fiber optic, it's very expensive, but also it's very fast. So when we want to transmit a huge amount of data, we rather to choose fiber instead of twisted pair, for example. Okay, coaxial is not is still being used a lot with a private cable system, but is not that speed. It's a medium speed. It's faster than twisted pair, but uh, slower than fiber optic. Okay. Uh, Talking about fiber, you need to know that not all the fiber is that fast. Okay, so you need to. I mean, there are a lot of different features or qualities in fiber, so you can choose a fiber which is faster or which is not that faster. Okay, so it's not certain that if you have fiber, it's gonna be fast. You need to how to say that. You need to see the data sheet of this fiber in order to know if it's or if it's not high speed. Okay. When we're talking about wireless transmission, we have radio waves or microwaves. We have satellite, and of course infrared. Okay. You already know that we have Bluetooth. Also, we have Wi-Fi and NFC and a lot of other technologies, protocols of transmission media, which doesn't use any cable. But those are the main transmission media in order to transmit huge amount of information. When we have, for example, one difference between for example, the radio waves and infrared is the use of this transmission. For example, I'm using radio waves when I want to transmit information through some maybe not that big distance, but for example, when we are transmitting a radio program or a TV show. But infrared is used more for short transmission in order to, well, talking about PLCs in the field. I mean, where the machine is and to know some information about the machine. For example, with the table number 3, the sensor which detects if the piece is black or white. This is a wireless device. Okay, so I'm telling you this for you to know that not just Wi-Fi is wireless transmission. Okay, well, networks can be connected in so many different ways. The easiest one is port-to-point connection. This point-point connection is the one that you do with the PLC and your computer. This is a connection that is between two devices, and that's it. Okay. But when we want to connect more than two devices, we need to use some other different topologies. For example, bus, ring, star, okay, etc. All of them has different features. For example, a bus communication is cheaper, but it's not fast, okay? Because if I want to send a message from one device to another device, I need to make sure that some other device are not sending information at the same time. Ring communication, it's also, I forgot to say that. If I want to make some maintenance on the network, I need to disconnect all the devices when I'm using bus communication. It's the cheapest, but it's also um, not the best one in order to make some maintenance. And well, ring communication allows me to make better maintenance because I can open just one part of the ring, and the rest of the devices can be still connected with each other. Okay. Star communication needs to concentrate all the information into one device, okay, in the center of the star. So this is could say that it's a fast topology, but also if the main device has a failure, all the network has a failure. And also it has high, I forgot the word, high demand on the network because I need to transmit from all the devices to the main device. Okay, so well, it's one of the disadvantage of that network. So those four are the basic, and then 5, 6, and 7 topologies are like a mix of the ones that we have at the top. 3, it's like something like bus and start topology together. It's a mix. Mesh, it's also like a mix or ring and star. And hybrid, it means I can have in some part of the network can be ring, some part can be a star, some part can be a bus. So I'm mixing some topologies. Those at the bottom are the most expensive because I need more cable or more um, a protocol which is more, how to say that, um, efficient in order to not to be crowded with information. Okay. Well, that was the first layer of the protocol. That was the physical transmission media. And then we have the second layer, which is data link. I don't know if you have noticed when you connect your Wi-Fi for the first time at home, that says data link, and blinks a LED. And when you set your modem, when you turn on your modem, it says data link connected. Well, data link, it's a part of the protocol that manage uh, or that controls that physical media. It means the physical media is the cable, but I need to control that cable. I need to transmit information through that cable. And data link is the one who do that. Okay. So it works with a local area network. It means the one that is on the room. And of course, manage the exchange of the data. It manages the flow of the data through the network and the devices which are using that network. And those are the main things that data link does: framing, synchronized flow control, and detecting some error, addressing, and well, one famous data link that we use a lot, it's Ethernet. Ethernet is the second layer of the OSI model, okay? And also point-to-point product or PPP, this one, okay? Those two are examples of data link, but those are not the only ones. You need to know that a lot of manufacturers can make their own protocol, and well, we have a lot of them. What is a flow control? I'm not going to stop on those layers too much. I'm just going to explain them very shallow. So, because we are not studying, I mean, these classes, we shouldn't concentrate on what it is a network, or to configure a network from the beginning. We just need to understand the main parts of the network in order to use them into the PLC. Okay. So, well, flow control is the way that the sender and the receiver communicate with each other. For example, one of the ways that data links use the flow control could be stop and wait. Stop and wait make that the sender sends some information. This information should be in a package, and this package goes through the receiver. Okay. Then the receiver sends an answer. Okay. And then the sender gives another package, and then the receiver gives an answer. This answer that the receiver backs to the sender is like a permission for the sender to send another pack of information. But those packs are very, very short. So this is a stop and wait. It's a very slow protocol or slow configuration. Okay. So it takes a lot of time to send a full file. So, well, it's not the one that we use the most, but it's the easiest one. Okay. For example, when we use stop and wait, the sender also gives information, and the receiver returns an answer. But I have some time, a predefined time to receive that answer. If the sender doesn't receive that answer on that time, then it infers that something wrong has happened with the communication. And we do basically the same with the go back architecture, but we are sending information. How to say that? I don't know how to say that in English. Una después de la otra. Okay? So, oh, yeah, one after other. We're sending information like this, and the receiver is answering, and we're checking using this timeout. But as you can see, we have to check. I mean, it's like a empalmado or something like this. It's more complicated, and it has to have a lot of synchronization in order to not to crash. Okay, but it's more efficient, of course, that stop and wait. Data link also needs to detect some errors, and the way that they detect some errors, it's with well, two different ways to do it. It's checking parity. Those are not the only ones, of course. And another one is cycling redundancy. That means that when the receiver receives some package of information, they make a division, a Boolean division, and they have a residual. And if this residual is 1, it means that something wrong has happened with the information. Okay, so ask to the transmitter to resend the message again. Okay, well, I'm not going to explain the error detection um, more deep. So if you're interested on checking what a network is and how to behave, you need to review some information on the website or on internet or Google or something. Okay. Layer 3, it's a network layer. This is a very important network because it's the one who manage all the address of the devices that are connected into the network. For example, one of the most used network protocol is Internet Protocol, which is IP. And when you have or when you connect to your computer to a network, whatever that network is, you have an IP address, right? So this IP address, um, it's very famous. We have heard of this a lot of time, and we know that this the address of our computer, but this address is given by layer 3, which is networking. Okay. uh, it not only gives us the address of the device, also the nodes and the servers, and it works. This layer works with best effort delivery. What this means? This means that this layer doesn't check if there are some errors on the transmission. This is not part of the work of this layer. For checking if there is an error on the transmission data, we have for layer, which is transport. This one is the one which controls if I'm receiving the right information of or if I'm not. Okay. So one famous protocol for transport is TCP. Okay. So when you connect your computer, when you connect or when you are connecting by first time your PLC to your computer, one of the protocols that are on the list besides MPI, it's TCP/IP. Do you remember? Well, TCP/IP is the internet protocol with um, TCP of transport. So it's two layers of the OSI model, the one you are selecting. Okay. Layers 5 to 7 are application layers. Those layers are helping me or helping us to display the information to the application that is using. For example, if I'm using, I don't know, WhatsApp, well, those three layers are the one who decodify the information in order to see my message on my screen. Okay. So as what I was telling you, I not always we not always use all the layers of the protocol. These 7 layers are just conceptual. So when we want to create a network, we need to choose some of those layers. And one of the famous combination, one of the most famous combination that we use is the TCP/IP model. Okay, that is the one that we can see on the portal when we are configuring our PLC. It's like a condensed version of OSI model. Okay, and well, now that we know mainly, so how a network is configured, the one that it's more interested for us in our PLC class is the industrial networks. Oh, wait a second, something has happened. Okay, I think that my slides has moved. Industrial networks. So what industrial networks are? Well, it's all the cables and the protocols that I need to communicate information into a factory. Okay, so let me see if I can. You can see better right there, right? Um, I'm sorry. This is new Windows, and I cannot. Ah, wait, I cannot. I don't know how it is, but well, okay. Well, industrial networks. I go out of the presentation because you couldn't see the last part of the pyramid. This is the industrial network pyramid. So you can find this figure on internet in most of the pages of PLCs. Well, it divides all the networks into a factory in some level. And the base of this pyramid is the field part. I think can you see it right there? It's field. Okay. So field, it means all the connections that I need to get information into the process, right through the machines. Okay. It means all the sensors, all the actuators, all the valves, all the motors, everything that you have there on the module. This is the field, network. Okay. So the connection with this, devices with the PLC, this is field, um, uh, part of the pyramid. And then we have control. The control part is the one that we are using with the PLC and some devices that help me to see what is happening on the process. Those devices can be HMI screens. Remember that HMI are the screens that, the operator has into the factory to see what is happening with the process, or in order to give some instruction, for example, an emergency stop or something. And of those two levels that are the ones that we are working with on this class, we are working with those two models, the field and the control level. Then we have supervision level. Okay. This supervision level, it says here SCADA. SCADA, it's like, uh, well, like application. Yeah, it's an application, that helped me to, well, we're gonna see it better on the next quarter, but I'm giving you some introduction to SCADA. SCADA is, an application to help me to get information from the system, from the process, and to make some decisions with that information. So through the SCADA, I can tell to the process, stop, go back, go further, give me more pieces, give me less pieces. Okay, so it's used to control a factory, but this is a main control. I mean, an HMI is a screen for the machine, specifically for the machine, but a SCADA, it's, bigger. It's for the entire, production line. I mean, can you understand that? No? Uh, well, I will give you, I have an infographic for SCADA. You're going to understand it better. I have an example for that. What, Homer Simpson does at work. Supervise. So he has a control panel, and he see all what is happening into the nuclear, what is that? Nuclear plant. So if something happened in the plant tells to Simpson, what is happening, and he has to make something, right? He has to push a button, or he has to sound an alarm or something. So what Homer Simpson does, his job is to check on this SCADA, this screen, and this, um, tablero. Yeah, this is the SCADA. Okay. Um, okay. The two higher levels on the pyramid are the networks that are used on the administrative part of the plant, on the management part of the plant, okay, where there it is human resources, financial, the accounting department, the assistants, the secretaries, the executive people. I mean, all that part of the plant. Of course, all the factories has to have offices. Okay, so they also need industrial levels. But there is something very important with this pyramid. We need to have a very high safety protocol between
In
those
those
two,
two,
because
because
we
we
cannot
cannot
just
just
go
go
into
into
the
the
into
into
the
the
industrial
industrial
part
part
and
and
modify
modify
something
something.
through the network. We have to protect that part of or machinery safety. Okay, so well, when you work on the industry, you'll need
Need
to
to
make
make
sure
sure
that
that
the
the
part of
part
the
of the
industrial
industrial
network
network.
which is in the factory be protected. Remember that when you load by first time your program into PLC, it gives you a warning that says you are not adding a security level for this PLC. Did you saw that message? Some of you saw that message? No, wasn't here. Well, to some of your classmates, I don't know, I remember if it was with you or in some other group, but when they first load the program into the PLC give them a warning that it says that they were not programming um, a safety protocol for the PLC. This safety protocol helps to others to download the program that you are loading to the PLC. For example, when you first connected to the PLC, you could see the program that your classmates from last quarter was programmed them, right? So if you program a safety protocol, then the next classmates from the next quarter won't be able to see that program. So your program will be safe. Okay. So we're gonna see a few of the main interfaces that we can be using. I don't know why it's doing that. Ah, okay. The okay. This interface is the one that you are using, the MPI. Okay, it's multi-point interface. And well, I think I told you. I don't remember to whom I told that MPS it's a proprietary interface. It means it belongs to Siemens and only to Siemens. No other company can use MPI. Okay, so it's the simplest communication for the Siemens automaton, and it's used to interconnect the program device with the PLC. So that's why we are using that interface to connect our computers to the PLC in order to program. It runs over an RS485 physical cable. This is the name of the cable, you know, well, the name of the cable. But it's not the only interface that use that physical cable. The Profibus, it means the purple cable that you're seeing right there, it's also RS585, 485 cable. It's the same cable, but it's different color and it's different protocol. That's why you, even though you can connect the MPI interface into the purple cable, it doesn't work. Okay? And well, it says that the speed of this cable is from I forgot how to pronunciate numbers. 187 kilobits per second to 12 megabits per second. Okay, that's the speed of the cable. It means that it's not a high-speed cable. It's just enough to program the device and to monitoring, but it's not to transmit huge amount of data. And you need to know that you can interconnect to 32 devices, 32, including the zero device, 32 devices to a network which is connected with MPI protocol. I mean, you are connecting when you are programmed just one device, your computer and the PLC. Well, two devices. But you can connect, you're able to connect more devices with that same interface. The only restriction that we have is that the number one, it means the address number one should be always for the programming device. And number 0, it's always for the PAN. And then we can name 2, 3, 4, 5, blah, 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 to the rest of the devices that we're connecting to the network. I think some of you had some problems with an interface that when you connect that interface, it says the address for the programming device is higher than the blah, blah, blah. It was a message that some of you received last week. It was you, or some of you saw it? Yeah, with the first module, right? Well, that error, it means that the address of the programming device, the computer, is not the appropriate, is not 1 or 0. In this case, it should be 0 because we don't have operation panel. But then when we saw into the setting, we saw that the 0 address was right program. So that's how we knew that the interface was damaged. Remember? Okay. Then we have some others. I think we're running out of time, but let's see if we can finish the presentation. Then we have some other different interfaces. I'm going to skip the field bus. We're going to see that next week because I rather to see Profibus. Profibus is the purple cable that we have connected into the models, okay? This purple cable is a second proprietary network. It means also belongs to Siemens and cannot be used for other devices, okay? And we have 3 different models of Profibus. And the last 2, DP and PA, are the ones that are mostly used on industry. DP, Profibus DP, distributed peripherals, is used to communicate the PLC with the devices that are in our machine. For example, my sensors and my actuators. Sometimes could be some sensors that has a communication model. I mean, more sophisticated sensors. The one that we are using here are very simple. They give me 1 or 0 if they are active or not. But there are some other devices, proportional valves, and some others that we'll see on 5th quarter when we see advanced PLCs that cannot be connected directly to an I/O module. I need a specific module to connect it to the PLC. And DP administrates the information between those two. Okay, the PLC and the peripherals, I mean drivers, sensors, IO, all those that are at the bottom of this image. And the process automation, it's has some difference. It runs in a different cable, as it says here. Profibus DP runs on the same cable that MPS, remember? That's why we can connect into the purple slot, even though it doesn't work.
Miss Guadalupe Angelina, we almost finished the class, right? It says that finishes in 10 minutes.
Yes, we have 10 minutes still.
Okay, I hope not to disturb the topic that you are explaining, but to me, this is so admirable because you are working with the students right now and wearing the mask face, the mouth face. Sometimes it's complicated. Yeah, I can understand that part. Okay, I have some questions to you in order to finish the assessment. How many students do you have?
Right now, count themselves. I think we are.
I just see 3 students.
Let me show you with the computer. With the computer camera.
Okay, it's better. Okay. So nice to see you, kids. Yes, we are from Tamaulipas.
Answer. Say hi.
Okay, over here, I can see some hands. Yes, I was thinking that I was just watching some electronics. Yeah, but you have students there in those tables. Yes. Okay, how many? At least 20 do you have?
15.
15.
We are in a classroom that allows just a few of them. The rest of them are not here. We divide the group.
Excellent, excellent. We understand that the pandemic it has been so complicated. Okay, another question is, what's the way that you were working before this week? I understood that you were working from home, right?
No, we have been working here since the beginning of the quarter, since September.
Okay, excellent. In
October.
hybrid lessons?
I'm sorry?
Hybrid lessons?
Yes, our class is mainly practical, so they have been working with the laboratory team equipment. But
daily, did they need to attend daily?
No, because they are. I mean, the presential. I don't know how to explain that. We are in kind of an hybrid model. Some of them are from home, and some of them are presential. So
okay,
they don't need to
want to
attend.
if they want to attend to the lab, they could.
Yes.
Okay, excellent, Miss. Okay, this is very interesting the way you are explaining. I really like it. Congratulations. You were talking about PLCs. I work in mechatronics at the Universidad Tecnológica de Altamira. Also, I can understand your topic. You were discussing about, yes, the flow control, the topologies. So this is very interesting. I really like the way that you were explaining, even with using Homer Simpson's example. This is to be engaged with the students. Congratulations for that. The way we work in class observation at Universidad Politécnica, that is the one that I represent today. In these processes, we ask to the professor, how's the way that you work with the evidences of your students, for example?
All my students have to develop a practice per week, and they have to upload it to our platform, which is Schoology. So they can work here at the lab, or they can work home with simulation.
Okay, if it's possible that you could show to me Schoology platform.
I'm sorry, I couldn't hear you.
Okay, if it's possible to you that you could show me Schoology in your computer.
Yes, of course.
Thank you. I would like to see some evidences of your students.
Some evidence, okay. Who wants to be shown? Okay, author B. Okay. paint pots. Those are all the practice they have already delivered. And who? Okay.
The main platform that you use is Schoology, right?
Yeah, that's Schoology. Oh, also we have here
A
a
homework.
graphic that is being designed right here at the laboratory.
Excellent. Thanks for your participation, students. This is
That's the way they deliver the practices through a video. They explain what they did and how it works.
excellent. Do they work in teams or is this individual?
They work in teams
Okay.
because it's a very heavy software. So not all of them can install it on the computers. Also, physically, we don't have one module by person, so we work in teams.
Okay, I understand that part. We are public schools. Excellent.
Yeah.
It's excellent to be working in teams. Mhm. Okay, do you have an attendance list or what's the way that
Yes,
you get this
we do have
evidence?
an attendance list. Let me show you. We do not, well, at least I'm not taking list all day, all days, just a few days like a sample.
Yeah, I understand that part. Yeah.
This is the data sheet where we have the grades, the missing practices, and also the assistance, the
Okay, and
attendance.
in our universities, yes, practice represents the 70% of the grade, right?
I'm sorry.
In our universities, the practice represents 70% of the grade, right?
Yes. Well, in my subject, it represents the 100%.
The
When
100, yeah.
when they have some theory, well, theory could have 20%, but mostly they do practices.
Okay, excellent. And then you have this quarter or this period working with them at the lab, but the previous quarter, how were
Yes,
things?
they should develop practices at home, also using simulator. So it was practices, but weren't physical.
Okay, what's the name of the simulator that you use with them?
Uh, for this subject, it's TIA4L. It's the Siemens software for PLCs X7.
Okay, do you have it in this computer?
Yes.
At least I understand that half of the students have this in their computers, right?
Yes. At least
Excellent, Miss. Okay. Do you use a lesson plan or a program that the university gives to you?
some program. I mean software.
No, the
You mean
lesson
software?
plan or a program of the unit where you can work
Okay,
and
okay.
understand unit number 1, 2, and 3. You said that you are now in unit number 3.
Yes, we do have this I mean topic list could be, well, the program, and we program the subject through this using this file.
Okay, excellent. Your class is very complete. Okay, congratulations to you, Miss, and to your students. Over here, I would like to say bye-bye, dear kids. Bye-bye, students. Thank you so much for your help and attention.
Thank you. Thank you for your attendance.
Thank you, Miss. Bye.
Bye.